Okay, today we're going to connect up this test rig that you've been issued with so as to prove Ohm's law, and the power supply is the adapter here which we can plug into the mains, so I'll do that. And we're going to use this meter as a voltmeter and this meter as a current meter. Because I know the voltage is going to be a maximum of 12 volts here, I can set this to 20 volts DC, and I'm going to set the current meter to 200 milliamps DC on this range here. So the first thing we're going to do is try and get the bulb lit. So if we connect the bulb positive to positive on the power supply and the negative to the negative on the power supply, you'll notice the bulb is now lit. And we can vary the voltage by altering the potentiometer here. So if we turn that right down, it goes out. If we turn it right up, it comes back up. So I now need to measure the voltage across the bulb. So if I connect positive to the positive of the meter, which is this middle terminal here, and the negative to the negative terminal, or the common on that meter, I can see now I'm getting a voltage at the top there, and if I turn that right down, you can see the voltage varies as I turn it down to 0. Like so. So I'll turn it right up for the time being. Next thing I'm going to do is measure the current in that circuit. So I need to break the circuit somewhere. It doesn't matter where, but the easiest place to break it is probably the positive here. And it's between this point and the terminal down there I'm going to place the meter. So I can connect the positive to there, and that goes into the meter here, and then the other side, which is coming out, I can connect to the common. And you'll see here I've now got 167 milliamps and 11.43 volts. And as I vary the voltage down to 0, both meter readings are reading virtually 0. So if I increase that to 1 volt, I get 46 milliamps. If I increase it to 2 volts, it goes up to 69 milliamps, and so on. And you'll probably notice even at this stage that it's not going up at the same rate, because the bulb is actually heating up, and once its temperature sort of stabilizes midway, you get fairly linear readings. To repeat the experiment on a resistor, simply pull out these two here from the bulb and put them across one of the resistors. And we'll see now that if I go down to 0, 0, increase it to 1 volt here, I'm getting about 4 milliamps. If I increase it to 2 volts, I'm getting approximately 9 milliamps, and then if I increase it to 3 volts, I'm getting 14. So it's a much more linear response across the resistor, and that's because the resistor's temperature doesn't increase as rapidly as it does in the bulb, because as the bulb's temperature increases, its resistance increases as well. Okay, so that's the basic setup for current and voltage in a circuit. So when you've been issued with the board, this is how you do it. If you need to have another look at it. Okay, thanks very much, bye.